Mary Wilson. I'm a professor at the University of California, San Francisco. I study infectious diseases, and I'm particularly interested in the topic called emerging infectious diseases and why new infections appear and how they spread through a population. I've been studying infectious diseases for a very long time, and it appears that there is always something new. I have seen the emergence and the spread of HIV, and then a lot of control of that. I've seen SARS, and now, most recently, SARS-CoV-2. So one of the factors that has had a profound influence on the appearance and the spread of pandemics and infectious disease generally is climate change. And there are three main areas I would highlight specifically. And the first one is vector-borne infections. These are infections that are spread by mosquitoes or ticks or other critters. And these are extremely sensitive to temperature, humidity, and rainfall. A second area that climate affects these pandemics and infections are through mass events, major events like hurricanes and floods. And the third way is that it shifts where animals and mosquitoes can live. And so it shifts the distribution of where these pandemics are most prominent. We have been seeing an increase in emerging infections, and in fact, if we look at the past 50 years or so, we have seen one infection after another or one pandemic after another. There are many factors for this. Climate change is a big and important one, but global travel and trade, the change in our environment, the deforestation, there are many other factors that have also affected it, but overall it has increased. So humans have really driven a lot of this increase in pandemics and outbreaks, and some of the reasons are the farming of wild animals, the trade in wild animals, the change in the landscape, deforestation, which will often displace animal population like bats. So we're seeing increased interactions between animals and humans, and these can lead to a spillover of a virus that is in an animal into a human. Some interventions we might consider to try to reduce the likelihood would include, number one, regulating some of the wild animal and the live animal markets. We can build more robust public health structures that include surveillance and the availability of vaccinations, but including surveillance that looks at, for example, wastewater as a way of tracking the spread of some of these viruses and potentially other things in the environment. Water is essential for life. It can also be a marker that can help us track what is going on in a population. But first of all, clean water and sanitation is necessary to prevent cholera and other diseases that can kill individuals and have caused pandemics and killed hundreds of thousands of people in the past. Today, looking at wastewater has also been a way to try to track what is going on in a population. So even if people are not seeking medical care for an illness, looking at wastewater can give us an insight into what is going on in a population and may give clues as to a potential outbreak before it occurs in a population, and it can allow interventions to be put in place very early on. Veolia has played a very important role in general in finding ways to provide clean water to populations. But Veolia has also more recently, starting during the pandemic, developed an approach to look for the presence of virus in wastewater that would allow interventions to be taken. This is a very powerful tool. Recently, it's been used to look specifically for SARS-CoV-2. This same tool, the same approach of analyzing wastewater can potentially be used to look for other viruses or chemicals or antimicrobial resistance, and is something that should be supported and expanded further beyond Europe, certainly to really other parts of the world. The analysis of wastewater uses tools that have been around for a long time, but also is an area where there's been innovations using new kinds of genetic sequencing, looking potentially at families of viruses that may not have caused epidemics or pandemics so far, but have the potential to do so in the future. So I think the field is at its very early stages right now, and I think there's opportunity for enormous innovation and progress going forward. One of the highest priorities for me would be to create surveillance systems using a One Health approach. And by that, I mean integrating information about humans, animals, and climate. With emerging infections, with pandemic threats, the greatest opportunity we have, if we cannot prevent them, is to detect them very early when they are very small, and then institute interventions to stop them or to contain them. I think people are worried, but they also need to know some things that they can do personally. And even though most individuals can't do something that may reduce the risk of a spillover event, they can do something that will not contribute to climate change. So I think every individual does have a potential role, but again, I think even understanding the nature of the risk is important. It's impossible to predict when the next pandemic will occur. All I can say is that I think there will be another pandemic. I don't know the size, the severity, the location, but we have created a world where we have put into place many factors that make it highly likely, if not certain, that there will be another pandemic. What we must do is to put in place the mechanisms to try to identify as early as possible what it is, where it is, while at the same time we reduce the factors that we know contribute to the risk for another pandemic.